Our today's topic for this particular video session is mechanisms of various chemical reactions. Or in general, I can say that mechanisms of different types of chemical reactions. Here, there are many types of chemical reactions. Say for an example, addition reaction, substitution reaction, elimination reaction, then we have rearrangement reaction and polymerization reactions. So they plays an important role in determining that which product will be formed by which particular type of reaction. So these are different types of reactions, and along with it we have to see that what is the mechanism of that. So in addition reaction or in another type of reactions, we get only and only addition of particular compound or particular atom or particular group in our compound. Along with it, we actually get another way, like in elimination reaction, only elimination occurs of that particular group. In rearrangement reaction, we can see that one group will rearrange its position. So it will move from either first position to the second position or to the third position. And in polymerization reaction, we can see that it is basically about that in polymerization, what will happen is n number of monomers combines with each other to form a long chain, which is known as polymer. So that is known as polymerization reaction. Now substitution reaction plays a very, very important role, because in substitution reaction, one atom is substituted by another atom. One particular group will be substituted by another group. So such kind of reactions actually plays a very important role in different types of organic reactions. And mainly alkyl halides and aryl halides generally follows SN1 and SN2 reactions. So that is nucleophilic substitution reaction number 1 and nucleophilic substitution reaction number 2. Okay, so we will take first of all nucleophilic substitution reaction. So nucleophilic substitution reactions are a group of reactions that involve the interaction of nucleophile with an electrophile. So I can say that here the attacking group or the attacking atom will be nucleophile, because it's nucleophilic substitution reaction. So what will happen? One nucleophile will attack on that particular substance and it will react, or it will remove the electrophile from it. So in this manner, it's possible that what we will get is basically the initiation will be done using nucleophile. Okay? So the electron-rich nucleophile attacks the electron-deficient electrophile. So what will happen here? The electron-rich or electron-dense center attacks on electron-poor center, or high electron density center will attack on low electron density center. So in this manner, this particular reaction proceeds. Okay, let's see how it goes. So A minus, here A minus is nucleophile. So A minus will attack on our compound, which is CR1, R2, R3 contains Q, right? So that particular compound will be attacked by our nucleophile. So that is attacked by nucleophile, and Q will leave the compound and becomes Q minus. It will leave that particular compound, while A, which is our nucleophile, will attach to the compound, to the main compound here. As you can see, Q is out of that compound and A is already entered. So A substitutes Q. Here A minus is the nucleophile, Q is the living group. There are basically two types of nucleophilic substitution reactions. Number 1, SN1, number 2, SN2. And each having its own mechanism. Both of them, it will have its own mechanism. Here S stands for substitution, N stands for nucleophilic, 1 or 2 refers to the reaction's molecularity. So SN1's molecularity is 1, while SN2's molecularity is 2. Okay, so nucleophilic substitution reaction and electrophilic substitution reaction, as I told you, right? As you can see here, what we will have is basically nucleophilic substitution reaction. This is a general nucleophilic substitution reactions mechanism. Okay, in general this will happen, but it occurs by two different ways. One way is SN1, another way is SN2. So as I said you here, Sa minus is the nucleophile and Q is the living group. There are two different types of nucleophilic substitution reactions, SN1 and SN2. So S for substitution and for nucleophilic, 1 or 2 refers for basically our molecularity. Now let's see that how it will actually plays an important role here. So SN2 reaction. First of all, we will see what is SN2 reaction. Okay. So SN2 stands for nucleophilic or substitution nucleophilic reaction number 2. Okay. Substitution nucleophilic reaction number 2. Molecularity is 2. This is basically a one-step reaction. The rate of reaction depends upon both of the reactants, that is on substrate as well as on nucleophile also. And that's why it is referred, the molecularity is referred as 2 and it is written as SN2. Now, the bond between nucleophile and carbon forms at the same time that the bond formation occurs between carbon and living group breaks. So what will happen here? Your nucleophile, the attachment of nucleophile and the living of the particular living group occurs at the same time because it is a one-step reaction. Okay. Now as you can see in the image, what we will have is CH3Br plus OH minus. Now this OH minus is nucleophile. It will attack on our CH3Br, that is an alkyl halide on it, and what will happen there? Br will break down, or it will be there or it will out from our compound, and O minus, OH minus will attack or attaches there. So there that becomes a transition complex, and that transition complex will further move ahead and Br will be removed while methyl alcohol will be formed. So Br minus is totally removed from the compound while OH minus is totally added in the compound. So in this manner, this is basically a one-step reaction in which transition complex formation occurs, right? And because of this particular one, we get such kind of product formation. Now let's talk about SN2 reaction. Let's study about SN2 reaction here. So this type of reaction occurs in two steps. It's basically substitution nucleophilic reaction number 1. Okay, so the molecularity is 1 and the rate of reaction depends upon only and only reactant. So in an SN1 reaction, the bond breakage and bond formation do not happen simultaneously. In SN2 reaction, what will happen? The bond breakage and bond formation occur simultaneously. The formation of transition complex is done there. Here, it will not be like that. It is like, first of all, the bond breakage will be done and then bond formation will be done. So we have here basically the leaving group departs first, taking the shared electron pair with it. This leaves a carbocation. So in first step, the carbocation formation occurs. Okay? And then nucleophile came into picture. Now, as you can see here in the image, we have an alkyl halide. Here R is equal to CH3. So carbon attaches with 3 groups of methyl, that is 3 groups of CH3 plus 1 Br is there. So that becomes an alkyl halide, one kind of alkyl halide compound on which nucleophile will attack. Okay, so at that time, first of all, it will not happen, or the nucleophile will not attach with the group. So what will happen? First of all, the Br will remove or will depart from the compound. So Br is highly electronegative, so it will bring the electrons with itself, creates a positive charge on the carbon, creates carbocation intermediate. As you can see in the image, what we will have is C plus attaches with another CH3, 3 different functional groups there. So that will create a whole intermediate which is known as carbocation. Okay. Now on this particular carbocation, which is electron deficient in nature, will be attacked by electron rich nucleophile. So nucleophile can attack from both the sides. Okay, as you can see in the image. So attack from either side will be done and we get our substitution product. Right? So nucleophile is totally attached to our particular compound. Right? Now let's take a look on electrophilic substitution reaction. So the substitution reaction in which the attacking reagent is electrophile called electrophilic substitution reaction. Here the aromatic compounds react by electrophilic aromatic substitution reactions in which the aromaticity of the ring system is preserved. For example, benzene reacts with bromine to form bromobenzene. Right? We will see here elimination reaction also. So an elimination reaction is a type of organic reaction in which 2 substituents are removed from the molecule in either or 1 or 2 step of reaction, and depending upon that we get 2 different mechanisms, E1 and E2. Okay, so they follows the same way as of that, but it's an elimination reaction. This is all for this session. Thank you so much.